Hello everyone. Thank you for joining short-term course on basic electrical engineering from Company Social Responsibility Activities of RTOC Indore under the National Skill Development Corporation. Myself Deepesh Bhati, Assistant Professor in Electrical and Electronics Department from IPS Academy, Institute of Engineering and Science. Now, this is a simple structure just like a building. But what will happen if the base of this building is weak? Again, I repeat, what will happen if the base of this building is weak? Definitely, the building will collapse. Now, the base of this structure should be strong. Some condition for engineering. So, basics of electrical engineering or base of electrical engineering is laws and rules in electrical engineering. There are some basic laws related to electrical engineering. First one, law of conservation of energy, Kirchhoff voltage law, Kirchhoff current law, Ohm's law, Faraday's law, Lenz's law, and Fleming left-hand rule. I will explain one by one. First, law of conservation of energy. Everybody knows that the law of conservation of energy states that energy can neither be created nor destroyed, only convert from one form of energy to another. I will again explain with the help of example. Example number one. It is the best example of conservation of energy. Water can produce electricity. Water fall from dam to turbine, hence converting potential energy to kinetic energy. And electricity convert with the help of turbine and generator and transfer to the field. Next, example number two. The object from highest point to lowest point, then potential energy decreases and kinetic energy increases. This is the best example for energy conversion. Now next law, Kirchhoff voltage law. Kirchhoff voltage law or KVL state that the algebraic sum of all the voltages in any closed loop is equal to 0. Simple. The algebraic sum of all the voltages in any closed loop is equal to 0. Known as the Kirchhoff voltage law. The animated view, this is the battery and this is the load. Now Kirchhoff current law. Kirchhoff current law or KCL state that the algebraic sum of all the current in any node is equal to 0. This one Q1 flow from incoming and divide into three parts, Q2, Q3, Q4. Now the incoming current equal to the outgoing. Hence Q1 equal to Q2 plus Q3 plus Q4. Again animated picture like this. This is the show Kirchhoff's current law. Now Ohm's law. Ohm's law, voltage or potential difference between 2 points is directly proportional to the current when physical condition being unchanged. Means voltage equal to current into resistance. Resistance is a constant proportionality. Hence V equal to IR. This is a voltage and output is current. V is directly proportional to current, but resistance resist this flow. Okay. Another example of Ohm's law in everyday in our life, conventional domestic fans. In conventional domestic fan, we can control the speed of the fans at our homes by moving the regulator to and fro. Here, the current flowing through the fan is controlled by regulating the resistance through the regulator for any specific value of the input. We can calculate the resistance, current, and power flowing through Ohm's law. Next, Faraday's law of electromagnetic induction. The first law of Faraday's electromagnetic induction states that whenever a conductor placed in varying magnetic field, EMF are induced, which is called induced EMF. If the conductor circuit are closed, current are also induced, which is called induced current. Same in the second law, Faraday's electromagnetic induction states that the induced EMF is equal to rate of change of flux linkage. The simple law, Faraday's law, I will explain with example. Okay. The magnet near to the conductor, simple, bulb is on, voltage fluctuate. Now Lenz law. Lenz law states that the direction of electric current which is used in a conductor by a changing magnetic field such that the magnetic field created by the induced current oppose the initial changing magnetic field. Now this equation EMF equal to minus n d phi by dt. This equation due to Faraday's law of electromagnetic induction and Lenz law. The minus sign due to Lenz law and oppose the cos. Okay. The next one is the Fleming rules. When current flowing through a conducting wire and external magnetic field is applied across that flow, the conducting wire experience a force perpendicular both to that field and the direction of the current flow. They are mutually perpendicular as shown the figure. The thumb shows the mechanical force, forefinger is a magnetic field, and middle finger is electric current. But same in Fleming right hand rule. But one problem always arises: which one use for motor or generator? Now, easy way to remember at different time is MLA. Is a MLA sub. MLA sub is always right. Then left hand rule used for motor and right hand rule used for alternator or generator. Okay. The next is magnetic flux. Magnetic flux is defined as the number of magnetic field lines passing a given closed surface, just like this. Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. Generally, a magnetic flux is commonly denoted by pi, and the unit of magnetic flux in SI unit of magnetic flux is Weber. The fundamental unit is volt seconds. The CGS unit is Maxwell. Now the magnetic flux density. Magnetic flux density is defined as the flux per unit area. Simple flux density equal to pi upon A, the unit of magnetic flux density in Tesla. Now the relation between magnetic flux density, field strength and permeability. Simple, B equal to mu into H means B is directly proportional to H. Mu is a permeability Permeability is the ability of the material to conduct magnetic lines of force, or mu equal to mu 0 into mu r. Now, the analogy between the magnetic circuit and electric circuit is a very most important topic in basic electrical engineering. Analogy between magnetic and electric circuit. Now, in analogy, I can explain similarities in magnetic and electric circuit and dissimilarities between magnetic and electric circuit. I will explain. So first one, similarities between magnetic and electric circuit. Now, basics, magnetic circuit and electric circuit. First one, definition. The closed path of magnetic flux is called magnetic circuit. Then the closed path for electric current is called electric circuit. Now, the relation between flux and current in magnetic circuit, flux equal to mmf upon reluctance, means reluctance oppose the flux. Same condition, current equal to emf upon resistance oppose the current. Now, unit, flux measured in Weber, same current measured in ampere. They all are similar, mmf and emf. Magnetomotive force is driving force and is measured in ampere terms. Same condition in electric circuit, electromotive force is a driving force and measured in volt. Now the reluctance and resistance. The reluctance oppose the flux or magnetic flux. Means S equal to L upon A mu. And the unit is ampere turn per Weber. And resistance oppose the flow of current. R equal to rho L by A, measured in ohm. Now the relation between permeance and conductance. Permeance equal to 1 upon reluctance. The same condition in conductance equal to 1 upon resistance. Now, analogy, permeability, magnetic circuit, conductivity in electric circuit, resistivity in magnetic circuit, resistivity in electric circuit. Density, flux density, flux per unit area, magnetic circuit, and current density in current per unit area. Now intensity, H equal to Ni upon L, and electric density E equal to V by D. Now the drops, mmf drops flux into reluctance, and the voltage drop V equal to IR. Now flux and electrons. This is a dissimilarity. At the point, the dissimilarity in first point, in magnetic circuit, molecular poles are aligned. Means flux does not flow, but set up in magnetic circuit. And in electric circuit, electric current flow in form of electrons. For example, for magnetic flux, there is no perfect insulator. It can set up even in the non-magnetic material like air, rubber, glass. But in electric circuit, there are a large number of perfect insulators like glass, air, rubber, PVC. Now, variation of reluctance and resistance. The reluctance of a magnetic circuit is not constant due to mu, because permeability mu equal to mu 0 into mu r. So, mu r is a relative permeability or relative permeability of the material. Material change, permeability change. But in the resistance, the electric circuit is almost constant because rho is constant. Now energy in the circuit. Once the magnetic flux set up in magnetic circuit, no energy is expanded. Only a small amount of energy is required at the initial stage to create a flux. But in electric circuit, energy is expanding continuously as long as current flow through electrical circuit, and this energy is dissipated in the form of heat. Now the applicable laws, Kirchhoff's law and MMF laws, and electric circuit KVL and KCL. Now the magnetic and electric lines, the magnetic lines of flux start from north pole to south pole. An electric lines or current start from positive charge and negative. They are all similarities and dissimilarities of magnetic and electric circuit. Next, machine. There are two types: static machines and rotating machine. Static machine means transformer and rotating machine means motor or generator. The efficiency of static machine is high as compared to rotating machine. Now, the first one, transformer. Transformer is a static device which transfer electric energy from one circuit to another circuit without change in frequency. It's called simple transformer. Now, transformer play a major part in the transmission and distribution of AC power. The basic fact that generation is inherently a production of alternating EMF together with the advantage of AC transmission using highly efficient stationary transformer become the main reason for widely speed development of AC system. Besides the above, transformer are also used in rectifier, starters, furnace, welding, traction system, casting, unit, etc. Now, as compared to the rotating machine, a static transformer is much simpler because of less complex interrelation between the magnetic and electric circuit. Next, transformer working principle. A transformer works on the principle of electromagnetic induction between two coupled circuits or coils. The primary winding is connected to the alternating source. Therefore, an alternating current starts flowing through NP turns. The alternating MMF NPIP sets alternating flux, which on the figure is a flux which is confined to the high permeability iron path, which on the figure. The alternating flux induce voltage even in primary side as well as secondary side. If the load is connected across the secondary, the load current starts flowing. This is an animation of principle of transformer. Next, classification of electrical machine. Electrical machine means machine can be used as a motor or as a generator. Motor means electrical energy convert into mechanical energy is called motor, and generator mechanical energy convert into electrical energy is called generator. Electrical machine, there are two types: DC machine and second AC machine. DC machine, again two types: DC generator and DC motor. Now, AC machine differentiate between two types: synchronous machine and asynchronous machine. The difference between synchronous machine and asynchronous machine: work synchronous machine work ns equal to nr principle, means rotor speed equal to synchronous speed, and asynchronous machine nr is not equal to ns, means rotor speed is not equal to synchronous speed. Now, 90% generator used as a synchronous generator. A synchronous generator, again two types: single phase and three phase. The application of synchronous generator used for generation purpose, and induction machine work as a induction motor. There are two types: single phase and three phase. Single phase use up to 3 HP and three phase use above 3 HP. Now the application of single phase induction motor used in fans, hair dryers, washing machine, vacuum cleaners, mixer, refrigerator, food processor, and other kitchen equipment employ their motors. These motors also find application in air conditioning, fans, blower, office machinery, small power tools, daily machinery, small farm equipment, and three-phase induction motor used for industry purpose. Okay. Next, I will explain one by one. First one, DC motor. The part of DC motor is stator, rotor, or armature, commutator, coil, brush. DC motor principle, when a current carrying conductor placed in a magnetic field, a mechanical force is experienced by it. By applying left hand rule, it is found that conductor has tendency to move left hand side or right hand side. Next one is the induction motor. The principle of induction motor. The motor works on the principle of Faraday's law of electromagnetic induction. When three-phase supply to the stator of three-phase induction motor, anytime rotating magnetic field is developed, the rotor conductor are stationary. Rotor conductor cuts the revolving magnetic field. Rotor conductor cuts the revolving magnetic field EMF induced according to Faraday law of electromagnetic induction. An EMF induced in rotor winding, the rotor is closed circuit. Due to this, EMF current will flow through the rotor circuit. This current is known as a rotor current. As the current flows through the rotor conductor, the flux induced on it. The direction of rotor flux is same as the direction of rotor current. Now, we have two fluxes. One flux in stator and second flux in rotor. The stator rotating magnetic field rotates at synchronous speed and the rotor flux behind the stator flux. The relative motion between the rotor and stator flux, the rotor flux will try to catch up the stator flux. According to Lenz's law, the rotor rotates in the direction of stator flux to minimize the relative motion, and this is how the rotor starts rotating. The rotor current produced by induced EMF, therefore this motor known as a induction motor. The animation of three-phase induction motor. According to construction, three-phase induction motor, rotor are two types. First, squirrel cage or wound rotor. Next, the difference between AC motor and DC motor. Based on some point, was nature of the input current. In AC motor, alternating current is the main input power in AC motor, and in DC motor, direct current is the main input power in the DC motor. Supply source. In AC motor, three phase or single phase power may be used, and DC motor, energy obtained from battery, cell, or power converter. Now, commutation process. Commutation process absent in AC motor but present in DC motor. Commutation process means convert AC to DC or DC to AC. Now, supply phase. An AC motor may be used both single phase and three phase supply, but DC motor only single phase supply is used. Number of terminals. There are three terminals used in AC motor: red, yellow, and blue. And there are two terminals, positive and negative in DC motor. Carbon brush. No carbon brush in AC motor, and there are carbon brush in DC motor. Now application. Suitable for large and industrial application, but DC motor used in small and domestic application. Starting. AC motor are not self-starting single phase induction motor, but DC motor are self-starting. Position of armature. The armature is stationary and magnetic field is rotating in AC. But in DC, armature is the rotating part and magnetic field is stationary part. Magnetic cost less expensive as compared to DC, but DC motor maintenance is more expensive. Thank you. Thank you, Ravi Sharma sir, Director of Auto Sales, for inviting me for this lecture. Any query, please contact me, my email ID. Thank you. Thank you very much.